One of the coolest relationships that we're going to see within the world of statistics is this idea that if we can quantify the amount of dispersion that we have in a distribution. So imagine a distribution looks like this. It doesn't have to look like this in all cases, but we can start to develop this idea that the further away from the mean that I go and the number of standard deviations, whether it's in either direction, but as this number of standard deviations go up, what we start to see is this percentage of values, the corresponding percentage of values go up as well. Now, I'm a big fan of starting to discuss this early in a statistics class because, again, I think it's just fundamentally that important. All right. Now, one of the ways that we can start to show this relationship between the number of standard deviations away from the mean that I go and the percentage of values is Chebyshev's theorem. Now, Chebyshev's theorem, or I think it's really, it's a theorem, but it's one thing to bear in mind. It's not very precise, but it's massively flexible in establishing this relationship. And Chebyshev's theorem states that the percentage of values surrounding the mean exists in basically this ratio 1 minus 1 over k squared, where k is the number of standard deviations away from the mean that you are. So again, we see that that the further away you go in the number of standard deviations, the higher this percentage of values is. Again, one last disclaimer. Chebyshev is not overly precise, but really great. It's in simplistic terms establishing this relationship between the percentage of values and how far away you are in the number of standard deviations. And of course, another disclaimer, the distribution does not have to look like this. It can look, basically take on any shape, any form, whatever the case may be. Now, as a way to look at this, if we look at an example and we talk about, here's a demonstration. On one of the first tests in BA 254, the data indicated that the mean score was 125 and the standard deviation was 10. What is the percentage of students that scored between 100 and 150? Again, I like pictures. I'm a pretty simple guy, but again, does not have to look like this picture, but one that's helpful is to say, all right, imagine our distribution just happens to look like this. Our mean value was 125. And our standard deviation was 10. Standard deviation was equal to 10. What we're trying to figure out with Chebyshev is what is the percentage of values that exist between 100 and 150. So Chebyshev only requires one put into his theorem. In this case, we could go in and say, well, what we first need to figure out is what is the number of standard deviations? Like literally, what is the number of these that fit in here between 125 and 150, all right? K is not, in this case, looking for 25 points, but trying to figure out literally how many of these 10-point standard deviations fit in there. Well, of course, the distance here is 25. How many of those fit in there? We have 2.5. We have 2.5 standard deviations. So if we load that 2.5 into our formula, 1 minus 1 over 2.5 squared. 2.5 squared, of course, it invariably happens when you grab your phone to use it as a calculator, somebody tries to call. But I take 2.5 times 2.5, I end up at 6.25. 1 divided by 6.25, all right? And if we take and simplify this even more, 1 divided by 6.25 gets us to 0.16. 1 minus 0.16 gets us to 0.84, or 84%. What Chebyshev's theorem leads us to say that, according to Chebyshev's theorem, the percentage of students that score between 100 and 150 is 84%. Now, one thing to point out with Chebyshev, when we talk about what represents this value of k, or this variable k, this is the number of standard deviations away from the mean that I ever am. So if I go out here at 150, I am 2.5 standard deviations away from the mean. If I go back towards 100, how many standard deviations away from the mean am I? 2.5. So Chebyshev requires us to basically be going kind of the equidistance away from the mean. Chebyshev, to summarize, has a ton of flexibility, but starts to explain to us exactly how this relationship between the percentage of values and the number of standard deviations away from the mean that we are. What I would challenge you in follow-up to this video is to go in and change these values around and see what happens to this percentage. Try going to 135 and 115 or 160 and 90, and you'll start to see this relationship come out, that these percentages change based upon how much of that distribution that you're looking at.